Hey, what's up, y'all? Thanks so much for joining me on today's video, 3 Shapes, 4 Colors, Part 3. Today we are going to learn how to write our own custom functions, as well as just review a few more shape functions that processing has included with it. So to get started, let's take a look at the syntax for custom functions, right? So functions that we want to write are going to need a return type. They're going to need a name. Some of them might need arguments. And then the code will go inside of the curly brackets. So one of the return types that we've been using is void, meaning that function doesn't actually return anything, right? Some other return types are float or int, right? But the ones that we've used so far mostly have been void, where they don't actually return any data or values. They just do something for us. They just run the code that's inside of the curly brackets, right? So let's start with a void. A function with return type void, right? Then we're going to give it a name. How about my function? If we need any arguments, they'll go inside of parentheses here. And then, of course, we're going to have some curly brackets, and our code will actually go here in between those curly brackets, right? So let's take a look at the code and see where some of those functions are, right? You can see actually setup and draw are both functions that have a return type void, right? So these functions don't return any values. They don't give us a float. They don't give us an int. They don't give us anything to use somewhere else in the sketch, right? They just do stuff for us. Something like map, on the other hand, right? This function returns a float, right? It's going to give us a value that is of the data type float, right? So this function might look something, it might look something like this, right? Float, map, and then here in the arguments you would have what, like the number and then the range, the two ranges, right? So you have 5 arguments here. You'd have your open and closed curly brackets, and then you'd have the code here inside of the map function, right? To actually do all the math that you need. So the map function might look something like this, right? So let's see how we can use functions with return type void to kind of clean up our code to make it a little bit more legible, a little bit more organized and readable, as well as easier to debug. So we can come in here and we can decide, okay, what kind of functionality, what kind of code do I want to put into this function? And I think what I'm going to do is take all of the code that draws my rectangle and put it inside of a function. So let's go down here below our draw loop, right? And we'll say void, how about draw rect? That's what I'll name my function. Right now I don't need to give it any arguments. I'll put the open and closed curly brackets, and then I can just take all of this code that I'm using to draw my rectangle and cut and paste it into the function, right? So now in my draw loop, if I run it this way, right, you'll see that there's not actually going to be a rectangle on the screen anymore. Right? That is all gone. But if I now make a call to this function that I just created, my rectangle comes back, right? And that's because when the compiler gets here to, what is this, line 22, where I've made that call to this function, draw rect, the compiler then is going to come down in here and say, okay, well, I have to run this function. What all is inside of it? Okay, push matrix, fill, rect mode, translate, right? I do all of these things. I exit this loop here, and then I continue reading and executing the rest of the directions, right? And you can see how much cleaner this looks, how much easier it is to read, especially because I've given it a kind of a name that tells me exactly what's going on inside of the function, right? And so this is also going to be a lot easier to debug if I wanted to make it more complex, right? So if I wanted my rectangle to look fancier or do something more interesting, all of the code I'm going to put in here, and if something goes wrong, then I know exactly where to come and look for the issue, right, with my rectangle. So that's a really powerful way to clean up your code, get it organized, and also make it easier to debug in the future. Let's quickly here then look at how we might put these tasks, right, where we're drawing triangles and ellipses here into their own functions. So maybe I'll say void draw ellipse. And I can take all of this code here, cut and paste, and as long as I make a call to that function while I'm in draw, I should get the exact same thing. Here we go. Good. And everything's still working. Okay, and then let's look at how we might do that with our triangle code here. So we can take all of this, cut and paste here into this draw triangle function, make a call to that function in draw, run the sketch. Okay, and now I'm getting the exact same sketch that I had previously, but much more organized. Look at how small and tidy and easily readable this draw function is now, right? So just one way that using functions can really help clean things up. Now, I might at some point want to draw this rectangle somewhere else, or any of the shapes other places, right? So let's look at how we can put some arguments into this function so that we can pass in values to the function that allow us to change things when we call the function, right? So let's see, if I come up here to my parentheses in my function and I say, okay, I am going to ask for a float x and a float y, right? Instead of hard coding these values that in my translate function, I can say, take whatever you were given when this function was called and put it here in translate. Take whatever you were given for y when that function was called and put it into translate, right? And you can see an error is now appearing when I make a call to this function because it's now expecting a couple of arguments. It's expecting two parameters that are of type float, right? Because that's what I put here in the actual function. So I can come here to my call to this function and I can just say, width divided by 5, height divided by 2. And this is going to allow me to pass in values to this function. And I can do that however I want. I could say mouse x. And so now, when I move my mouse left and right, the x position of this rectangle is getting drawn wherever my mouse goes. Okay, cool. So now y'all know how to write your own functions. Let's take a break from this sketch and look at the other drawing functions that come with processing here. Okay, so let's make a new sketch. Usual setup and draw. We'll do the same resolution. We'll make our background white. And let's start with the quad function, right? So this one you can see is expecting 8 parameters. And what it's asking for are the x and y positions, right? X0 through x3 and y0 through y3, right? So it needs 8 of these different parameters. It's asking for the 4 points of some irregularly shaped polygon, right? So let's just do for a demo here. How about this? Let me draw something actually like this. Let's make the origin of our window here. This is going to be our quad, and now we can calculate the position of each point. So this would be -1, -2, -1. This is -2, -1. This one would be +2, -2. This one would be +1, +1. And this would be -1, +3. Right, so these would be the 4 points of this quad that I just drew. Let's put it into our code, see what that looks like. So I can say -2, -1, 2, -2, 1, 1, and -1, 3. And that is all the arguments that it needs, right? Let's go ahead and say push matrix and pop matrix. Let's translate to the center here and run our sketch. Okay, and you can see I get a really, really tiny quad here. So I could do a couple things. I could scale it up. Let's say I say scale 50. You can see that gets much bigger. It scales the entire thing, so the stroke gets scaled up, right? So everything gets a lot bigger. Another way of kind of making this a little bit bigger is to use like a variable that can kind of control. I could use to like multiply all these numbers. So what if I say int quad size equals 10, right? I can say times quad size times quad size times quad size. And now I'm going to get something that's a little bit bigger, right? Because I'm multiplying all these numbers by whatever this is. You know, if I wanted to be able to control that in real time, I could say, probably actually I'm going to need a float here. How about between 1 and 100? Right, so this is another way of just kind of changing the size of a shape. Right, but this is how quad works. Okay, so let's get this out of our regular draw loop. Let's say void draw quad. Okay, and let's move on to the arc function, right? So this one is similar to the ellipse function, but you can see here it's expecting 6 parameters instead of just the 4, right? And this one is going to need the x and y position of the shape. It's going to need the width and the height, and then it's going to need the angle that you start, right, and the angle that you end, right? So I'm using theta here to represent those two angles, angle 0, angle 1, right? And what it's going to do is you're going to tell it, where do I draw it? How wide and how tall is it going to be, right? And then how much of it do I want to trace, right? So what I just traced was all the way from 0, right, to 2 times pi, because that's a full rotation. If I put something like 0 to pi for those last two arguments, I would get something that looks more like this, right, where it's just drawing from 0 to pi. If I put something that that said pi to 2 pi, right, I would draw this with the arc function. Okay, so let's look at how we're going to put this into our code. Let's go back to the code window here, and we'll say, how about width divided by 2, height divided by 2, 100 by 300, and 0 to pi. Let's see what we get. Should just get the bottom half of this ellipse. Right, okay, awesome. So this is how arc works, right? You can see if I wanted to go to pi all the way to 2 pi, I get the top half, right? Okay, so the next one that we'll look at is the line function. I think that one's so simple I don't really need to draw this one out for you. You just need 4 arguments, the starting coordinate and the ending coordinate. So let's say that I wanted to draw a line from the top left down to the bottom right corners. I can just say line 0, 0, width, height. Cool, and this will allow you to draw straight lines. There are a couple different different functions that you can use to draw curved lines. The one that we're going to look at is called Bezier, and this one needs 8 different arguments, right? So you've got the starting and the end point, and then you've got 2 control points that kind of pull the curve in different directions, or pull the line in different directions to create the curve, right? So let's do this so you all can see how this works. I will say fill 0 ellipse. We're going to do the starting and ending points here with black dots here. So I'll say width divided by 2 and 0, 10 by 10. Height, right? So that will be the beginning and ending points of our curve here. And in between these start and end points, I need 2 control points. And we're just going to put these at the same place so y'all can see what they look like. So I'm just going to say mouse X, mouse Y, mouse X, mouse Y. So I'm stacking these two control points on top of each other for now. Then we'll say fill 25500. So we'll color the control points red, and there's only one right now. That's not what I want. And we will say mouse X, mouse Y, and then we'll say no fill here. And this should give me the starting and ending points, the control points, and this line. Okay, great. So you can see, right, that as I move these control points around, it's going to pull the line in the direction of the control points to create a curved line. Let's move one of these control points somewhere else. So let's just say that we put this one all the way at the right side of the screen, and we put it sort of 3/4 of the way down. So we can say that. And then we would need one more control point since we moved this one here. And now you can see there's a control point all the way down here. And if I stack them up on top of each other like they were before, we get that same kind of curve. But now I've got another point of control that I can kind of use to influence this line, right, to get some nice curvy lines. This is a quadratic implementation of the Bezier curve, right? You got 4 points. Cool. Okay, so let's now look at the p-shape variable, the p-shape data type that comes with processing. It allows us to store shape information in a variable. Okay, so I'm going to kind of clean this up for a second. Let's get rid of all this, or maybe let's just say void draw Bezier, store this somewhere else for a minute. And the first thing we want to do is we want to come up here and declare a variable of p-shape type, like this. Let's give it a name. How about my shape, right? And then there's a few ways that we can initialize this shape, right? The first one, we can do this here in setup, is to just use one of the primitive functions, the primitive shape functions inside of a call to create shape. So we can say my shape equals create shape, right? And then let's say I wanted to draw an ellipse, right? So I can say ellipse, all caps, and that will now expect the 4 arguments that I would use for a primitive ellipse. So I might say something like, how about 0, 0? We'll draw this one around the origin, and we will say that we want it to, again, be 100 by 300 pixels. Then here in our draw function, we can do our regular translate to width divided by 2, height divided by 2, and then we just make a call to the shape function. We tell it what we want to draw. We want to draw my shape. Okay, and here we go. We've got our ellipse, right? So one of the reasons we might use a p-shape is if we want to have a lot of the same copies. We want to have a lot of copies of the same shape on the screen at once. It's actually faster to save the geometry of that shape inside of a p-shape than it is to create it every single time in draw with the actual shape function, right? So that's one way we might use that. Let's look at how, if we were doing that, we would also change the stroke and fill of the shape. So we would say my shape dot set, let's say stroke for a moment, right? And oh, we're gonna actually, for this, we're gonna need a color variable. So let's take a look at that, right? So processing also has color variables that you can create, right? So I would say color C, and then here I can say C equals color, and then I'm using my RGB values here. So now this color is equal to red. So I can set the stroke with that color, and that will be red, right? And so if I run my sketch, I now have this red outline, right? If I didn't want a stroke, I could say false, right? And then I could say, you know, if I need some fill, my shape dot set fill, and then I can use that same color variable, which was red. So now I should have a red shape with no outline. right? So now you can see there's no outline. So that's how I can set the stroke and fill of P shapes that I've created, right? Let's look at another way that we can create shapes using P shapes. So instead of our primitive, what we're going to do is use begin shape and end shape, right, after we've created the shape. So we'll still have to say my shape equals create shape, but we won't give it an argument in this function. Instead, what we're going to do is we'll say my shape dot begin shape, right, and then that will need to be followed by an end shape at some point, right? And let's maybe just do something really simple. We'll kind of make a quad, even though we could use quad. This is just to kind of show y'all, if you wanted to make a really zany shape, or you wanted to have include like curved lines in a shape, you could use Bezier vertex, right? If you wanted to have like a shape where you cut something out of the middle, you could use begin contour, end contour, right? So I'm just going to show you the basic way of using begin shape, end shape with the vertex function, and y'all can check the reference for a little bit more of the advanced ways you can make some crazy looking shapes here. So you have a calls to begin and end shape, and then in the middle you're going to add some vertices, right? So my shape dot vertex, right? And so if I make one, let's just make a really simple rectangle. I could say 0, 0. And then let's put one over here at width divided by 2, 0. Let's put another one. Actually, let's make this 5 points. Why not? So let's go 1, 2. How about one that's over here? We'll say width divided by 3, 2 times width divided by 3. And height divided by 2, right? We'll add another vertex. So we've got one here, one here, one here. Let's put this one like over here. So we'll say width divided by 4, 2/3 of the height. And then the last one, let's put over here. So we'll say 0 and height divided by 4, right? So I've got 5 vertices here in this shape. It's going to be a 5-point shape here. And this is where all of the vertices lie. And so I think, what am I doing? Okay, right? So if I don't translate to the center of the screen, right? This is looking pretty much how I expect. I'm missing the little side on the shape on this side here. That'll be a little easier actually to see if we translate it to the middle. Right? So you can see I'm missing this little side here. So I would need to come and say close. Right? So now that side is closed, and for us to see the whole shape, now you can see the whole thing, kind of an irregular 5-sided shape here. So you can use these calls to the vertex function in between begin and end shapes to create your own custom shapes, which you're not, sort of restricted to putting these vertices in any order. You can kind of put them wherever you want. Okay, and then the last thing that we're going to do is look at how we can use P-shapes to group a bunch of different shapes together to create forms from those simple shapes. So let's take this and comment all this out for a moment. And what we're going to do is we're going to say, how about face, left eye, right eye, and mouth. And also we might want a head shape. Okay, so what we're going to do is first we are going to define all 4 of these parts of my face, right? So I might say head equals create shape ellipse 0, 0, and let's make this 300 by 300. Let's make the left eye also an ellipse, right? And I'm going to draw this one a little bit left of my origin, so I might say something like -50, and a little bit above the origin, which is where the center of the head is, right? So then I would say something like, let's do also -50, right? And let's make this one like 20 by 20. And then let's take the right eye, and instead of going to the left, let's go to the right of the origin. So we'll say positive 50, and then again above the origin 50. And I want it to be the same size as my other eye. And then for my mouth, I might say something like create shape arc, right? And then I can say this one, I want it to be x is 0, y. Let's go down a little bit. How about like 100? And then how wide and tall do I want this to be? Let's make this like 100 wide and 50 tall. And now I've got all 4 of these shapes, right? And I can group them together by coming up here and saying face equals create shape group as the argument in create shape, right? Now I can say face.add child, and I can say head. I can say face.add child left eye. This would need to be right eye. And so I can say face.add child right eye. I can say face.add child mouth, right? This is now a group that can contain all of these children. I can come in here and I can say, what am I drawing? Face? Is that the name? Yes, right? And let's do this so we can move our face around with the mouse. See what we got. Let's see how this face looks. Oh, of course I forgot to tell it how. Okay, so how about 0 to pi? Okay, not too bad. Maybe I want to play around with this a bit. The arc is too far down, and I don't think it's wide enough. So how about, or tall enough? So let's say this is only 50, and let's make this a little bit taller of a smile. Okay, that's looking cuter. Anyway, you can play around with, where you put the eyes, what you make the smile look like. But hopefully, after watching these 3 videos, you've got a nice foundation for how processing works, how to use code to draw things. So I'm going to encourage you to take 3 shapes, 4 colors to its limit, right? Reimagine this piece as something like n shapes, n colors, where you can change n to be any value that you want. You can have as many colors and as many shapes as you want. Use all the functions that we've gone over here to take this piece and make it something unique and your own. I'll see you in the next video.